We are now welcoming Shane and Justin to the stage, who will give us a presentation on NBA team shot selection efficiency.
Hello, my name is Justin Ehrlich. This is Shane Sanders. We'll be presenting our paper on estimating NBA team shot selection efficiency from aggregations of true continuous shot charts, a generalized additive model approach. So we're adding two elements to shot charts. The first is we are using GAMs, so generalized additive models, to create continuous shot charts. So GAMs allow for fitting nonlinear relationships using splines which are perfectly fitted for hard boundaries such as the three-point arc. The second aspect is that we are incorporating missed shots that draw shooting fouls and shot pursuant free throw scoring to determine total scoring yield following a shot decision, which we call true points. In terms of scoring yield, other shot charts are more like field goal percentage or maybe effective field goal percentage. Ours is more like true shooting percentage, hence the name true shot chart. So what have traditional shot charts been telling coaches and players? Here we have the expected value of 2s and 3s. And you can see the major gap between 2s and 3s, right? So obviously, why would you take a shot, a long 2 that's worth 0.8 points in expected value, when just a few feet away, that's a shot is worth 1.2 points, so 0.4 points more. So this is the basis of the three-point revolution in the NBA. Also, we have a time trend here of three-point attempts. We see a blip in the 90s. That's when the three-point arc was moved from 23.75 feet to 22 feet, and then back to 23.75 feet. But you really see it skyrocket after player tracking was introduced. So that first bar, that's going to be Sport View in 2010. Then 2 years later, so the first bar is 4 arenas. The next bar over is all arenas. And then finally, Second Spectrum took over in 2017. Here is our shot chart. So notice it is continuous. And we are estimating expected true point value of all shots, field goal attempts or not, continuously from each half-court spot, while including shot pursuant free throw scoring. We also have a Bitly link where you can interact with the dashboard, where you can compare player to player and team to team. And this was created by our student, Nicholas Kamimoto. Here's another example. This is going to be James Harden's 2019-20 season when he won his third consecutive scoring title. So it's interesting because you can see on the baseline, the left baseline, 2 long 2s, we have high scoring yield. And you can see that because it's red. In the traditional shot chart, it would be all blue there because those would be very inefficient shots, as you can remember from the expected value plots. But our true shot chart shows that these are high yields, and we can see why with the difference chart. So this difference chart is just taking the difference between our true shot chart and the traditional shot chart. And what we're seeing is it's just the value added of free throws. And again, this is James Harden's 2019-20 season. And we can see here that James Harden's added value of shot pursuant free throw scoring throughout the mid 2s and long 2s. His ability to draw fouls across the court and into long 2s adds tremendous value in terms of true points. So what are we measuring with true points? We're measuring both proficiency, which we already explained, but also volume. So our volume is measured as shot attempts, including field goal attempts and missed foul shots, which are not typically included in shot charts. So our fix to the volume distortion of traditional shot charts are akin to the sabermetrics movement away from at-bats to plate appearances. This is all because shot attempts are possessionally costly in expectation and should therefore be tracked whether a field goal attempt or not. Well, what can we do with this proficiency in volume? We can simulate a grid across the half court, and then we can create a new metric called shot selection efficiency through the use of Pearson correlation. So this provides a much needed means of distilling shot chart information down to a summary measure. Whereas traditional shot charts required a judgment call, ours gives you an objective single measure to tell you whether a team or a player is efficient in their shot selection ability. Now, because we created a new metric, we need to validate that metric. And to do that, we need to control for shot ability, for shot making ability. So what we did is we created the shot, we created what's called exogenous shooting ability for validation purposes. This measure is the average expected true points for a player or team if he or she takes a shot from every possible location on the half-court grid with equal likelihood. This measures shooting ability, but is exogenous of shot selection in that it weighs each shot location equally. And then this variable will serve as a control when measuring the effect of shot selection efficiency on overall team offensive efficiency. And so I'll turn it over to Shane.
Thank you, Justin. So here are our main two models for validating this new shot selection efficiency measure. And essentially, they have the same right-hand sides. We're looking at the relationship between some measure of team performance, Pythagorean expected wins in the first model, which was first adapted to basketball by Daryl Morey in a 1993 paper. In the second model on the left-hand side, we have actual win proportion. And in the third model, we have net rating per 100 possessions. On the right-hand side, of course, we have shot selection efficiency, but conditional on exogenous shooting ability and a vector of controls that align with the other four factors not represented in those first two variables. So essentially, we want to get at exogenous shooting ability because you have these players like Kevin Durant who can get away with less shot selection efficiency and still be proficient in scoring. So controlling for just our baseline, we want to know our teams and players getting more from shot selection efficiency. So here's our first set of results, our primary results. And you'll see in the boldened row, the coefficients on shot selection efficiency are positive, highly significant. So this is a robust result that shot selection efficiency is, this validates that it's contributing to team performance in the NBA from our data period 2016 through 2023. Shot selection efficiency is win productive in the NBA, even conditional on a team's exogenous shooting ability and its productivity across other components of the four factors model. A 1 standard deviation increase in shot selection efficiency will give a team in a season about an expected 1.64 wins during that season. So it's a pretty substantial effect. These models are highly explanatory, so they're not suffering greatly from such things as omitted variable bias. They explain between 67 and 76% of variation in team season expected win percentage across the models. We can go a step further in a supplementary set of models and ask, is shot selection efficiency not only win productive, but in a way that's not totally accounted for by payroll? Is shot selection efficiency Moneyball? So we estimate another model to consider the payroll conditional effect of shot selection efficiency on team success by adding the features payroll normalized and payroll normalized squared. The new model considers whether shot selection efficiency is at least partly an extra payroll source of wins in the NBA. And we see in this model, the models are identical on the right-hand side, other than the addition of the payroll features. And we still see in the boldened row, shot selection efficiency is positive, highly significant. And so the interpretation of this is even controlling for team season payroll, shot selection efficiency is productive of wins in the NBA. So shot selection efficiency is at least partly an extra payroll source of wins. We again explain a high proportion of expected win variation in the NBA through the model. About 73% of variation in team performance is controlled in the right-hand side. Shot selection efficiency is further validated in an alternative approach using XGBoost machine learning model. This gets a little in the weeds, so please refer to the paper if you're interested, but I will tell you that it is qualitatively equivalent to our regression analysis. And now to our primary application, which is, does an NBA three-point attempt premium remain in true shot charts? So we've all heard about the three-point premium and the change in behavior it's caused during the NBA analytics era. But we want to ask, if we're not aggregating shooting performance from conventional shot charts, but from true shot charts, do we still observe this? So to consider this question, we aggregate both from continuous true shot charts and traditional shot charts for all NBA shots taken in each season from 2016 through 2023. Doing so allows us to estimate the three-point premium with and without shot pursuant free throw scoring in each season. And then we develop time trends on the three-point premium for each season. So the red line on top, of course, is the three-point premium, the estimated three-point premium in each season if we don't consider shot pursuant free throw scoring. So the red line is from the aggregations of conventional shot charts. And if you look closely, it shows a positive and significant three-point premium through the 2020-21 season. Okay. And it never shows a significant three-point dis premium. If we look at the blue line, that's from aggregations of true shot charts. So it takes into account shot pursuant free throw scoring. It shows that since 2018-19, the NBA has encountered a three-point attempt dis premium that's significant and deepening. Okay, so if you remember one of the original slides Justin showed you, why is it deepening? Well, volume is continuing to increase, okay? And that means volume of two-point attempts is continuing to decrease, so that's contributing to it, as we'll see. So what is happening? Two-point attempts are getting more efficient over time as the mid-range is cleared, while three-point attempts are largely holding steady in terms of expected value. Players are shooting more, but players are getting a lot better at shooting them. Different types of players are getting better at shooting them, so it's kind of holding court. But two-point attempts, because of this massive reduction in the mid-range, they've gotten more efficient. You could say too efficient for an equilibrium to hold. We can zoom in on this a bit and say that persistent mid-range reductions created and raised two-point attempt expected premium by increasing the probability that these types of shots were made and fouled on. Preferred mid-range spots should be reclaimed by some shooters and some teams. Chris Paul was right, at least on the margin. Not all mid-ranges are bad. This does not have to kill the NBA's offensive spacing nirvana. It's about somewhat recalibrating where you pull up, not where you station. Some conclusions. Continuous true shot charts answer fundamental questions about shot efficiency in basketball, such as whether, when, and why a three-point attempt dis premium arose in the NBA. They do so by considering scoring from the field and free throw line pursuant to all shots from the field, and also by measuring shot proficiency and volume with spatial continuity. We also introduce a summary measure for any shot chart, shot selection efficiency, as the correlation between true scoring yield and shot volume across the half-court space. Lastly, we validate shot selection efficiency as not only win productive, conditional on other factors of basketball production, but also as a Moneyball source of wins in the NBA. Thank you.
Hello. Okay, great. Hi.
Hi.
Great presentation. I have a whole page of questions, but I'll try not to go through all of them. First, just a quick. Let me just make sure I understood this. So at the end, you said that the 3 points are now starting to we've saturated or even turned around on their value. You said because the mid range is clear, because those shots are now less contested or something.
Yes, so teams are opting to shoot a lower rate of their overall shots from the mid-range spots. So some teams have reduced the mid-range, the whole shot chart down to, it's been kind of a reductionist approach. So either in the paint or using the whole three-point arc. I've noticed some teams have gone whole games. I think it's been said gone whole games or even maybe pairs of games, not shooting either outside the paint or beyond the three-point arc. So, in game theory, we think about mixed strategy Nash equilibria. Mm-hmm. And so if you're in a mixed strategy Nash equilibrium type of problem, then just completely taking something off the table, even if it's not a dominant strategy, can be a bad idea. So, some of the preferred mid-range spots that we're actually seeing in these true shot charts perhaps should be brought back moderately as maybe a second option. In some sets, maybe a third option, I don't know, but the rate should be brought back.
And I guess, how does your model see that, right? Because your model isn't trying to, your model knows what is the percentage of shots I make from mid-range, and it knows, did I get fouled? So is it that because they're less contested in mid-range, you're making more of those shots, or is it because you are giving them credit for making a free throw after the foul?
Yes, so I apologize that due to time, we didn't show our models on the 3-point premium.
Yeah.
We just showed the trend lines. So you're right that the models we showed didn't get at that, but essentially the models that are showing the significant 3-point dish premium, they look at just how many points you scored either from the field or line pursuant to a shot. And then we use an indicator variable on the right-hand side, which says, was this a 2 or a 3?
Yep.
So it's a very just scaled down model. So it's saying, what type of shot was it? And then, how much did you get? And so that dummy of whether it was a 3 or a 2 is significant from the true shot charts. Now, how do we know what types of shots? That's from these shot. We've gotten league-wide shot chart analysis by year, analyses by year, and also that also represent the volume in the discrete shot charts, and that's coming from that. Yeah.
I see. Okay, let me do one more, and then hopefully, if we circle back around to me, so I love the efficiency metric you have. So you ran that with your true values. If you ran the efficiency metric with just the sort of the standard like effective field goal percentage or something, do you get a similar efficiency, or does your true shot value matter a lot in that efficiency metric?
It matters more in the true.
Yeah.
So we ran it both ways, and it just the coefficient's higher for the true.
Yeah.
Like a lot, or
I can't remember the specifics.
We presented a similar paper at Harvard Nessus recently last fall, and we had the distributions. It was left shifted.
Yeah.
There was less of a correlation when you didn't lump in the free throws for teams. So what that means, so it's right shifted for the true shot charts slightly. What that means is teams are recognizing, obviously, that these shot pursuant free throws are valuable, and they're hitting their hot spots, even taking somewhat into account these free throws.
I see.
And just to give you a sense, because we didn't get it in our final slides, but shot selection efficiency, this correlation metric, teams really know what they're doing, but some teams really, really know what they're doing. So this ranges from, I think, about 0.3 to 0.65 or something. So it's an easily interpretable Pearson correlation. But some teams really understand. And if you take into account on any given play, another set of 5 players are trying to stop what you're doing, a Pearson correlation of 0.65 is high.
it's super high, yeah. It's super interesting. Maybe we'll circle back, but I'll pass it on.
Thank you.
No, we're not getting back to you. I got too many questions. So you get the true score as a correlation. Can you clarify exactly what is the correlation between?
So it's volume and proficiency. So we take a grid, we simulate a grid of proficiency using our GAMs along with volume. And so we have, I think, a 50 by 50 matrix, and then we're just correlating just those two matrices together for team level and also for player level.
And how did you define the exogenous shooting ability?
So we simulate as if the player is taking a shot equally across the court. So we're just simulating like playing here, shooting here, shooting here. So we're not just taking their true shooting percentage. We're actually taking their, we know what their shooting ability is at each spot throughout the court, and we're saying, okay, if you have no efficiency, just randomness throughout the court, this is your true ability of making shots.
We're taking their average across all those spots. So it's almost stylized like the 3-point shootout. Like we're taking any agency away from the player. We're saying you're shooting here, you're shooting here, but we're doing it statistically based on their actual empirics. And if they shot from each point equally, what would be their expected points?
Okay. What about, real quickly, who are the better shot selectors or the worst of note?
The Lakers are the best. The Pacers are the worst.
Players.
The players.
Players.
We don't have.
A lot of the high, we had a top 10 at one point, but a lot of the high free throw rate guys like Jimmy Butler and James Harden, they really know what they're doing, getting the and ones. Yeah. LeBron James, these high free throw rate guys are trying to get to spots because they know they're hedging. They know they can either make the shot or get bailed out of the line. So we see a lot of value added in the shot selection efficiency for these types of players.
I see you motioning, so are we out of time for the most part? Okay, I'll circle back then. We're fine. He pretty much answered my question. I was going to ask, like, there are 30 NBA teams, obviously 400 players, total. I was just curious, like, what made you choose James Harden, and specifically that 2019 season. I know you said that was like the third year that he led the NBA in scoring, but you pretty much kind of answered that when you like put him along the same lines as Jimmy Butler with the N1 and LeBron. So we're fine.
Yeah, I'm sorry, I'm not very terse with my answers, but I will say his difference shot chart, because of his free throw rate, it really pops. The value added from calculating his true points as opposed to points from the field really pops because of his ability to get to the line at that time.
Understood.
Yeah, thank you.
Okay, all right. Thank you, guys.
Okay, thank you.